So let's get started monitoring our applications using Prometheus. These days, almost all applications are containerized, so it makes sense to run Prometheus inside a Docker container. You can run the official image on its own, and you can find it at prom/Prometheus. But before I run that, I need to expose port 9090 that Prometheus runs on outside my container. And I also need to specify the config file. So I've got this Prometheus YAML file here, and I'm just going to go to the docs on the Get Started page and copy in the basic example which they give. And what this does is configure Prometheus to monitor itself. And that's going to pull in a bunch of metrics which it exports. And then I'm going to bind mount this configuration file to the container. So I'm mapping the config location to the location inside the container where Prometheus is going to look for it. And that's going to allow Prometheus to access it. Now let's run that. Now that that's running, I can access the Prometheus UI. And to do that, I just go to localhost, which is my machine, and then to the port, which I've mapped into the container on the port where that container is serving Prometheus. And here's the UI. And before we get into that, you can see all the metrics which it's currently scraping if you go to /metrics. Because like I said, Prometheus is running its own web server where it's exposing that /metrics endpoint. So this is all the data which Prometheus is sharing. And this is all in the specific Prometheus format, where every metric has a type and a help. Back at the UI in the root, you can see a bunch of things, including the targets. If you click on that, you can see where it's scraping from. And here you can see that it's scraping itself. And we can write queries to explore those metrics. And to do that, we use Prometheus's own query language, PromQL. The simplest query we can write is just the name of a metric. Execute that, and then firstly you can see the results in the table. So here's the value. But you can also see it in a graph. And you can check out the documentation to find out all the different metrics exported by different exporters and exactly what they mean. And you can add filters to your queries to filter down those metrics using curly braces. Inside there you can put key value pairs. And there's different operators like equals or not equals. We can also specify key value pair filters, which we call labels within braces after the metric names. And we can apply multiple labels at once by separating them with commas. Looking down here, I can see all the metrics tracked and I can see some of their different labels. So if I just wanted to get this one, for example, I could filter by handler equals this. And you can also specify a time frame using square brackets on the end of all that. But you can only see table data when you do this. If I wanted to see that on the graph, then I can just change the duration here. If you enter an invalid metric, then it's going to look something like this. And if your syntax is wrong, then you'll get an error. By default, Prometheus logs a bunch of hardware metrics, but often you want to be able to log custom metrics. For example, you might want to know how many times some Python code encounters an error. So we can make a custom exporter in Python. And that's what I've got here. I've imported the Prometheus Python client, and from that I've got a function called start HTTP server, and one of the key metrics in Prometheus, the counter. Here I create an instance of that counter. You can check out the docs for all the details of how to do that, but it's basically name of the metric and description of the metric. And then I've started the server on a particular port and continue to increment that counter. And what calling this function is going to do is start serving these metrics to the /metrics endpoint for whatever machine this is running on. And that's just like what any other exporter needs to do. So in this Prometheus YAML, I've specified two different jobs. The first one is the default Prometheus, and the target for that is scraping itself. And then I've specified another target, which is my Python container. And that's because what I'm going to do is I'm going to set up Docker Compose so that it maps that name to whatever IP address the Docker container running the Python code starts up on. And so just to quickly check out my Docker Compose file, I'm building two images. One of them is Prometheus, and I'm binding my config file to it. And then the other one's Python, which I'm building from a Docker file, which is very simple. And then I'm specifying the image. And then I'm going to run Docker Compose up to start those containers running. and now they should be talking to each other. And so to check that, I'll go into Prometheus UI, and now Prometheus has created some metrics called myMetric followed by some suffix. The total, for example, that's going to show the total value of the counter over time. And those are the very essentials of Prometheus.